Wayne?
I'm in Nairobi.
Oh,
Nairobi.
sure.
Yeah.
Wayne.
Yeah, I'm here.
Are we, are we live?
Um, I'm just showing the poster as we
Okay.
wait on to start.
So, like, we should wait for you, like, tell us,
No, I'm actually
right?
ready. So whenever Alan is ready, we can just like start.
Okay.
Yeah.
I will introduce him and then, oh, you will, I guess.
Okay.
Okay, just give me a minute. I will tell you.
Sure.
Um, mhm. Okay, so I am ready. Are we good to go?
Yes.
Okay. So, hello once again. Welcome back to our second session of the day. And we will be having Allan Situma, who'll be a speaker today. And he'll be taking us through um, maintaining data pipelines. Yeah. Yeah, SQL data pipeline. That's what he's going to be talking to us about today. And Alan is a data analyst at Apollo Agriculture, focused mainly on maintaining SQL data pipeline with data build tool, that is DBT, and many other tools here. So, Alan, we are glad to have you on board. Are you ready to, teach us your
Uh,
ways?
yeah, I'm ready. Let me present.
Okay.
Let me
We're so
see.
glad to have you.
Thank you, thank you.
Yeah.
I hope everyone can see my screen.
Okay. Yep.
Yeah, it's one.
Yeah.
The creating a
A
simple
simple
SQL data.
SQL data pipeline.
Yeah.
Yeah.
Thank you, Tabitha, and the whole like GDG Nairobi community for this opportunity. So today I'm going to be talking about creating a simple SQL data pipeline with some GCP tools like GKE, Cloud Composer, which is managed airflow, and DBT, a tool that I'm really excited about and learning. And then there is I know so many people are wondering SQL data pipeline. Most people used to hearing Python, Scala, and all that. But yeah, there is hope for all the SQL guys out there. Um, so a bit about me. I am a data Apollo Agriculture, and what we do at Apollo is we use satellite data and machine learning to enable like better credit decisions for farmers in order to like give them all farming inputs that they need. That is, be it like fertilizer, and what this and we are like an extremely like low touch we use an extremely low touch model. That means everything is tech driven, and we're a heavily like software and data driven like from how we execute, like how we build our core software systems, to even like how we manage our data pipeline. So the implication of this is like, unlike traditional data analysts, I have to take up and apply like most of these software driven principles that are there. That is things like version controlling like my data model, CI/CD, doing testing, and to the point of like automation. So the motivation behind me giving this talk is so that I can be able to, give more hope to like data analysts or business intelligent developers who like only know SQL, a bit of Python, that make their life easy and they can get into the software, development culture so that you can manage pipelines easy. And then in the end, I will just, it won't be like coded, but I'll just give an overview of like how this can be set up in a GCP environment without like much DevOps knowledge because of the many tools that GCP have. So let's start with the problem statement. So there are two scenarios. One, like the one-man data analyst team in like a growing startup that is like fully dependent on data for their decision making. And the other scenario is you are a startup before, like you're one man, and now the team is growing. Like you have many analysts coming into the team. You have engineers also interested in like helping you out with like the data analysis work. So with these two scenarios, we see like this presents a problem. So like when you're more than one, that means like your SQL code, whatever to explain the business processes, should be version control. Like when a change is made, one analyst should know like there's a change that was made. And there's also testing that needs to be happen. You can't like abstract a business process and then just deploy it at your end users without like knowing whether the end result of the data is okay. And then something else is sometimes, as your team grows and you're using just a simple BI, it's usually tough to know like where some queries are sitting, like what query was written where to explain what business process, like where is it. And most of the times you end up like you find yourself like you're creating like redundant code. And then if you're a one-man team, that means you'll be getting like and your organization is like heavily data driven, that means you'll be getting like a ton and a ton of like requests, like left, right, and center. And usually the last thing is like the data is in a mess. And when I say the data is in a mess, like to an analyst, the schema is like, so the schema looks like this on the left time, like it's heavily normalized, and it can take you even connection to like 4, 5, or 6 tables in order to like explain who a customer is in your organization. And as an analyst, you need to like turn it into the view on the right, that is like a star schema, that is it in just like one line of code or 2 line of codes or like 2 joins. You're able to like get your data fast and easy. And in that situation, sometimes it feels like this, like you're running, everything is on fire, you act cool, calm, and you're getting all those requests. Queries are all over anyway, it's getting hard to test. You don't know like what is happening with your queries, like the BI process. Some dashboards are broken, one dashboard breaks, and that means you have to look for, you have to go like 10 queries deep to like just fix the problem. But that is all fine. So in the end, with this talk, what am I going to like teach you, and what are the expected learnings? You will end up knowing like the useful GCP products for like managing your data pipeline. You'll learn something about like software-driven SQL data modeling and some useful tools. I'll touch on a bit about like 2 tools, that is structure.rest and DBT, which is the main one. And then also I'll just talk about like overview of how to like set up a production ready data pipeline. So with all the problems that we've outlined, and so now what is the solution? So the solution is adapting a framework of thinking called analytics engineering, which is a rather new framework of thinking. That is, it is analytics engineering falls at the intersection of like data engineers and data scientists and like analysts on the other end, who um, who like your day-to-day work is to like bring the software development culture to like managing your data pipelines, and also I'm trying to like make sure everything runs well. And this is a new thinking that has been largely driven by a company called DBT, who came up with a framework, and they're trying to like make the problems that you outline, they're trying to like solve that and smoothen that out, like for analysts. So this is how it looks like in a typical company setting. Like you'd see where data engineer falls in, where an analytics engineer falls in, and a data analyst. So as you can see, like by the 4 points outlined there, definitely it's just applying software practices to like manage, clean, test, things like continuous integration, like Eddie has talked about, like to the data process. So before I now start looking at the tools and how to set up and how to get into that, what I wanted to like talk about, like, what does software driven data modeling means. That means that you get your code, your SQL code, your small analytics code, like version controlled and reviewed. There is automated testing, there is environments out there, there's documentation for your model. Your code has to be modular, even if it's like SQL code explaining business process. You don't have to like repeat the code elsewhere. You can just write one model that produces a certain type of data or table, and then you can reuse it like in your model. And then package management. So all these things are covered, and they're all under like the DBT tool. So now getting to the tools and the solution that I was talking about, typically now the pipeline, this is how the pipeline will look like. And it's composed of this image here represents like Cloud SQL. And the reason why I choose to talk about like Cloud SQL here instead of like the more mainstream like data warehousing solutions, that's because like this is like a typical like reflection of like my day to day. Like due to some certain data constraints, you're still forced to like use traditional DBs to do your process. And that's why I mentioned Cloud SQL and especially PostgreSQL. So on top of that, I'll talk about like how to set up DBT. So you use DBT to just model the data that is in your analytics DB. And then after that, probably you have like normal version control software. Let's say like you're using GitHub or GitLab. You push your code to GitHub, and remember these are just like SQL files. And then after that, like you build using the repository that you've pushed, you build a Docker image, and then you push it to the Google repository. I think it's called Google Image Repository. And then after that, that image is like loaded to Kubernetes, and then the orchestration and like the workflow is managed under Cloud Composer. And Cloud Composer is just a managed version for Airflow. And when you think about it, like if you're coming from a traditional data analyst environment, like most of the tools that GCP has offered you, that means you don't have to like set up and worry about like the DevOps environment, like provision of instances and stuff like that. Kubernetes like auto scales. If you want to like make your work easier by using Airflow, you don't have to like install Airflow. You have Cloud Composer. So now let me dive into the individual tools and like how we set them up. And first of all, I'll start with DBT, and I'll start with DBT and how DBT is set up. So from the website from the DBT website, this is the drawing they have there, and what they wanted to show is like where now DBT sits and the functions that it does. So you'd have like raw data in your let's say in your analytics DB, in your warehouse, it can be like a Postgres, can be Redshift, Snowflake, or BigQuery. And then on top of that, you have DBT now. DBT is just like a normal, it's just a CLI tool that is not embedded into your database. It is separate, so it just connects to your database and then runs, transformations, and then like stores them in like a separate schema or table, just depending on what on like how you've defined and set up the structure. And then that in the end is like easily used by BI tool. So if you have your BI tool, you don't have to each and every time, you're querying your directly like your tables, you're querying your tables, and that's annoying. um Good. Some bit of stats about like DBT and like where it's growing. And and it's like really important part of this talk. Like DBT has, it's a framework that has been heavily adapted like in the past few years. You can see like the growth. They do like a 3x growth each and every year. So many analysts are adapting like this kind of working framework, and this means it's going to be like the future. It's going to be the future of like analysts. um yeah. So with that in mind, and thinking about DBT, how is like the modern data analysis set up? So analytics today with the analytics today and how it's evolved, it involves like a couple of things. You have like data integration scripts, you have high performance analytics database, you have a lot of like SQL and R and Python and visualization tools. And as you see, these are like separate systems as opposed to like how it was before, where everything you do sits in under one managed SaaS system. And with all this, you find problems and you realize that this kind of setup requires a kind of workflow whereby you have like models that need to be tested, you have that need to be version control, you have to make sure that code is the SQL codes that you have don't only work in your computer but they work elsewhere. And you make sure like the code is deployed, it's monitored daily and everything. So when you think about this, like just tying to back to Eddie's talk, it's like what Eddie was talking about, but more of like a from like a data analyst point of view. So I've mentioned like DBT and what it's all about, but I didn't go like into into detail what it is. So DBT is just a collection of like SQL files and YAML files, and but the main part of DBT is the SQL files. Like you'd be, you don't have to. There's SQL, sorry, and then SQL that is needed, and then there's also like a bit of Ginger templating just to like help you be flexible as opposed to like just writing SQL or SQL like the normal way. So this is how like the file structure looks like, and I've taken this like as a direct example from the website so that you can see how easy it is. And on the right this side you can see the file structure, which just looks like a normal, it looks like a normal software file structure. You have the readme there, you have analysis, you have like a way to put in data, a way to like define the environment of your DBT project. You have things called macros, and macros, like it's written with Ginger templating, and it allows you to like do let me say ninja stuff. If you want to do like really meta for loops in your SQL query, you can write them as macros. And then the main thing of DBT is the models, and the models are like just basic SQL .sql file. So if you're defining like a simple table that joins, you want to see like the number of services that a customer has received, you can just select customer ID, count all, and then from customer join to services and something like that, and have that as .sql, and that will be your DBT model. And then you have snapshots, and then we have like one interesting thing here, that is the tests. So now you can see now how it's starting to come in together. It's one whole framework that includes tests. There's no clear like showing documentation, but yeah, there's a file that stores like documentation and how it's generated in the end. And with this, so connecting to your database, in this case, like if it's the Cloud SQL database, is as easy as you have when you set up DBT locally. I forgot to mention that it's a Python package. It's as simple as, like, for guys comfortable with Python, it's just pip install DBT, and it creates like this file structure for you, so such that you don't have to think about that. And then to connect it to your DB, there's a file called profiles.yaml file that is created in your system, and you just go and type in, your credentials to your database, and that's it. Like, you've connected your database to a framework that can help you, do business abstractions very easily, have your code modular, do tests, and also in the end generate documentation. So with that file structure and everything, and you've defined, you've done some business abstractions on your data and everything. So in the end, you have, like, a star schema setup that is in files. How do you deploy this? How do you automate this process such that in the end, if you're an analyst, your work will be just be editing those SQL files, and changes are committed, and everything automatically shows up to your database. So there are different options to deploy DBT out there, but since in this case, I'm going to, like, just focus on deploying in a GCP environment. So the first option is to, you create a Docker image of your DBT repo. Let's say you committed to GitHub or GitLab. You create a Docker image in case of when, a merge happens, and then you push that image to you push that image to Kubernetes, and then using Cloud Composer and just like basic Python, you write like a simple Python scripts. I'll explain like how Airflow works. You just write a simple Python script and push it to Cloud Compose. Set like a schedule, be it that data to transform like every, one after every 1 hour, and then you can also like add a layer of, like, documentation. The other two options, I won't mention them first a lot. That is, like, you import your repo as a module into Airflow. That is, Cloud Composer always creates for you a folder in cloud storage when you set it up. So, you can do this, which is rather, the last two options are a bit janky, and you don't want to find yourself in that situation. So the best option here is to go like with option one, which is like very minimal energy on your end as a data analyst with minimal software skills and everything. um, Let me just explain a bit about, like, why Kubernetes is important in this place, in this setting. um, and so this is an image of, like, how in the past, like, people have been deploying their services, like from the traditional deployment to like the modern deployment, where we hear everyone is talking about containers. Like, for data analysts, that's completely like new term. It's confusing, everything. um, and we are just used to like hearing our software teams talking about like container, throwing all the words like Docker and images and all that stuff. That concept is pretty useful for data engineers, in that it helps you, Kubernetes helps you like deploy DBT in this case without thinking about, like, provision of like the operating system, like how do I create a VM, all those things. um, so you don't have to like talk about you don't have to think about those, like, when you're deploying to a Kubernetes environment. So that's an overview of Kubernetes. So how do you go about this, like, in a general case? Like, this is just a general outline of how you go about, like, deploying something to Kubernetes, and this in this case, DBT. So first you just build a container image of your DBT repo, which is as simple. It's just 3 lines. It's this simple. So, you're an analyst and you're getting scared of this process. it's not that hard, and most of these templates are online. So you just create an image of your DBT project. There are many DBT like Docker images in Docker Hub there. So you can include that, or you can create your own Docker image if you know that. And then with these 3 lines of code, you have your Docker image that you'd push to Google Container Registry, and then after that, it's pushed to Kubernetes as like a container. So with that, with your image there, so how do you make sure that it is, run after X hours? Or if you have a testing process and you have a documentation process, like how do you make that happen? And how do you build dependencies such that if testing fails, it's not like deployed, the model is not deployed to production, and in the end, people don't get bad data. So that you use, there's a whole thinking called like workflow orchestration and management. And the most popular, there are very many tools. There's Luigi, but the one that I don't want to say it's popular, but commonly mentioned and people are so comfortable with is Airflow. So Airflow is is a savior. So as if there is anyone who's dealt with like Linux systems, or like tried to develop a workflow locally, you know that you use cron. And cron is like, it's written in terminal, and it can be pretty scary learning all that syntax and stuff. So Airflow makes this easier. It helps you to, like, programmatically author workflows, schedule when something is going to happen, and also even like monitor what's happening. Um, with with that in mind, so Airflow, how does it do that? It does this by creating things called DAGs. DAGs, graphs, like direct, by the time direct acyclic graphs. I won't get into that right now, but it's just, tasks organized such that they're dependent on each other, such that if one fails, the other one doesn't fail. Um, and how does Airflow is has a UI? That's the good thing about it. And I'm sorry, this is not that clear, but this is how the Airflow UI looks like. And pretty simple. You can view everything, it's that way. And the good thing about this being in Cloud Composer, it's already installed, it's provisioned, and all that. So as an analyst, you can work with your engineering team to just like set up Cloud Composer for you, and your work is just editing, the DAG files, and pushing them. You zero DevOps, energy on your side. Your work is to just focusing on data modeling. And below here, this is what a DAG looks like. So as you can see, like, it has dependencies. So in order for this to work, you have to this has to run, the first stage has to run, and and it flows that way. And what you can, in a data modeling setting, how this helps you is, you get your data, you've already written an SQL model, you have it tested, if the testing passes, you have it, create documentation on it, and if that passes, you have it deployed. So makes things easier. And so I took like a sample to just like show how, after you've set up, Cloud Composer has been set up for you by, let's say, your engineering team, or you can do it. So this is like the end details. And what I wanted to like specifically show is, you see there's a DAGs folder that is always created. So it's easy for you, even if you're so mechanical, you can always just copy whatever, like the DAG you've written. And talking about DAGs, this is how a sample DAG looks like. Like, it's just Python. It's basic Python. You don't have to think about it a lot. And for most of these things, you'll find them, you'll find like simplified tutorials, or you'll find like templates online such that you don't have to write this. So in our case, you just have to like import these few packages that are inherent in like, then Google, and this would help you easily. Now from there on, this is how you now define how to run a DAG. So this your basic like default arguments, like your email and all these things, like those communication services between, like if you want results to be sent to somewhere and stuff like that. And you this is how you define, yeah, a DAG basically is just like a task that you define it. So generalize like definition of it, and then you'd have, this is how basically you'd, for in, if you were using like the if you'd gone back to like the different options of like deploying DBT, if you'd chosen to like copy your DBT files to like GCP directly, and you aren't interested in using Kubernetes, that's when like things like the bash operator come in. But yeah, with this, I just wanted to show like generally if what like how like the feel of how a DAG file would look like, so that it's not scary in a data analyst mind. So it's just Python. You can learn these things over time, a bit of Python, writing various imports, and it's direct and stuff. And then last image as I conclude my presentation. Um, on the back end, I just wanted to show like on the back end, like how the composer environment looks like. So this is just for you to like visually get familiar with how the composer environment looks like, how things and where they're executed. And yeah, so as I conclude this, I'd, I'm hoping I can get to talk and even join the study jam and just show like the practicality of this. And I'm compiling like the whole talk so that I can have all the code seated somewhere in my repo, so that it can be easy for guys to access it. But overall, in general, it's that easy, with the few tools, using Airflow, which is like managed, Kubernetes, all in GCP, and then you have you have DBT. And I'd really insist on guys to check out DBT if you're starting out in the analytics space. DBT, and then you have your GCP environment, which is very, it's tailor made for you, not to, if you're an analyst and you're scared of like setting up VMs and stuff like that, you have already managed services for you in GCP, and all you have to concentrate on is like how to define your business abstractions in your SQL. Make sure that is tested, make sure documents are generated, and everybody is happy with the product. So thank you all. I'll hand it to Tabitha, and if there are questions, I'll be here. Yeah.
Thank you so much, Alan. Yeah, for taking us to that wonderful presentation. All about DBT, SQL, stuff like that. Thank you so much for taking your time to take us through that. Let me see. Yeah, so there's a question here. So concerning everything we talked about today, how easy is that in comparison to using MySQL?
From my understanding, okay, if I can understand the question, MySQL is a database, right? And DBT works on top of MySQL. So the same codes that you write within MySQL, you just transfer them to DBT. So it's a very easy transition. Like I can tell you, you can get set up in less than 5 minutes. Pip install DBT, you go to your projects file, transfer your MySQL credentials there, and slowly look at like the codes that are permanent in your MySQL DB, and then just transfer and create like SQL scripts in DBT. So easy as that. Yeah.
Okay. 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 That is interesting. Someone from the audience is saying they thought they knew SQL until they saw your presentation. Amazing stuff. Mm,
Yeah, thank you. Yeah, and it's like really exciting to learn. Very simple, and it's like a new way of thinking about, like, as analysts, we no longer have to just be in the background. We can talk software with other teams and everything. Yeah.
okay. That
Mm.
that is very interesting. Thank you so much for the feedback, dear audience. Yeah. Well, once again, I will thank you. I know I'm saying out of thank you, but yeah, this is really, it's huge having you on board, talking to us about all these things. Oh, yeah, there's also another question for you.
Yeah.
Uh, how easy have these tools helped you in your company?
Ha. Yeah, that is, if I can explain my journey, when I started. So Apollo is a really great place, and at that time I was given like the opportunity to be a data analyst. I had this view that, that time I was pumping myself up, I'm a data scientist, but when I went to Apollo, I found a
Mhm,
completely different culture. So when I joined, we worked with a tool called Redash, where everything was there. And that time was like really grateful. My team member was the CEO, so really good at writing SQL. So we used to work together. But now the problem with that is, like, he used to write his code and I write my code. Sometimes we find, we've just done the same thing, or we've defined logic differently, tables don't match and stuff. So it became chaotic. Like, it was really chaotic. And our CTO came up and told us, you know what, there's this tool called DBT that can make all your lives easy. And true to his word, it made it so easy. Now I've written, like, in the past when we were migrating to DBT, there are some SQL files that I've never touched. I wrote them once. They define like the business process ever since the business started, and they just continuously, upgrade. They continuously update. So like much of my energy has even moved from writing SQL here and there to more of like thinking about, the data infrastructure. How do I optimize it? Like, it reduced the amount of SQL that I write, I think, almost by 80%. And it's really wonderful. Yeah, so I hope I've answered that question. uh,
Uh, wow, that is amazing. I could actually feel, the
mhm.
energy, the
Yeah,
passion you have for DBT, and you can
yeah,
actually advocate for it anywhere. That is really interesting. Yeah, that is
yeah,
amazing.
yeah,
Yeah,
yeah.
that was really an informative session, and I hope we have learned one or two from Alan's, presentation today. And yeah, so once again, we are going to jump into our next session for the day. Yeah, I'll be covering something else, but still on the cloud, cloud range. So yeah, thank you, Alan, for your presentation. And guys, the link to the next session, I believe, has already been shared on the chat section as usual. So yeah, just drink some water and get ready for the next session. Thank you so much for joining us for the second session.